Assalamualaikum. Myself Dr. Ansari Farzana with Zama, Department of Chemistry, J.A.T.rts Science and Commerce College for Malegaon, for Women, Malegaon. Welcome all of you. Now in previous section we have seen some terminology, that means wavelength, frequency, wave number and relation between the frequency, wave number and wavelength, and interaction of radiation with matter. Now today we shall discuss about some terminology used in absorption measurement. The first important terminology which is used for measurement is radiant energy. Radiant energy is nothing but the energy transmitted as electromagnetic radiation. It has the properties of both particle and wave motion. It is characterized by wavelength and frequency. The relation between wavelength and frequency is nu is equal to C upon lambda, or lambda is equal to C upon nu. Where lambda is the wavelength in centimeter, nu is the frequency in per second, and C is the velocity of light, 3 into 10 raised to 10 centimeter per second. The wavelength of electromagnetic radiation varies from few angstrom to several meter. The units used to describe the wavelength are 1 angstrom is equal to 10 raised to minus 10 meter, and this is equal to 10 raised to minus 8 centimeter, and this is equal to 10 raised to minus 4 micrometer. 1 nanometer is equal to 10 raised to minus 9 meter is equal to 10 angstrom, and this is equal to 10 raised to minus 3 micrometer. 1 micrometer is equal to 10 raised to minus 6 meter, and this is equal to 10 raised to 4 angstrom. 1 millimicron is equal to 10 angstrom, and this is equal to 10 raised to minus 7 centimeter, and this is equal to 1 nanometer. The wavelength may be expressed in angstrom, nanometer or micrometer depending on its magnitude. Micrometer is preferred term in place of old term micron. Similarly, nanometer is preferred term in place of the old term millimicron. Angstrom unit and nanometer are widely used for ultraviolet and visible region of the spectrum, while micrometer is the common unit for infrared region. Electromagnetic radiation possesses a certain amount of energy. The energy of a unit radiation is called photon. It is related to the frequency by equation E is equal to h nu is equal to hc upon lambda, where E is the energy of photon in erg and h is Planck's constant, which have the value 6.62 into 10 raised to minus 2 erg second. It is obvious that shorter the wavelength or greater the frequency, the greater is the energy. The gamma ray, X-ray region are higher energy, while radio or microwave regions are of lower energy region of spectrum. Now second one is radiant power. It was formerly known as intensity. Energy per unit time is called power. Radiant power is the rate at which energy is transported in the beam of radiant energy. It is the quantity measured by a detector such as photocell or even by thermocouple. The radiant power incident upon a cell is given by the symbol P suffix 0, and that of transmitted by the cell is denoted by the symbol P. Now transmittance. Transmittance is denoted with the letter T. It is simply fraction of incident power transmitted by sample. It is the ratio of radiant power transmitted by sample to the radiant power incident upon the sample, both being measured at the same spectral position and with the same slit width. That means T is equal to P upon P0. It is usually expressed as percent transmittance. Therefore, percent transmittance is equal to P upon P0 into 100. Now, absorbance. Absorbance, it is denoted by the letter A. It was formerly known as optical density, OD, or extinction. The absorption is the logarithm to the base 10 of reciprocal of transmittance, where pure solvent is reference material. Therefore, A is equal to log to the base 10 of 1 upon T, or this is equal to minus log to the base 10 of T, और दिस इज इक्वल टू ट्रांसमिटेंस क्या है हमारा P अपॉन P0. नेगेटिव सिंबल है, नेगेटिव सिंबल हटाएंगे तो क्या हो जाएगा log to the base 10 of P0 upon P. Absorbance is also defined as logarithm to the base 10 of ratio of radiant power incident upon the sample to the radiant power transmitted by the sample. Now, absorptivity. Absorptivity is denoted by the letter small a, formerly known as extinction coefficient or specific extinction. Absorptivity is defined as the ratio of absorbance to the product of length of optical path and the concentration of the sample. Mathematically, you can write small a is equal to absorbance capital A upon B into C. A is the absorbance, B is the path length, C is the concentration. It is also called a specific absorbance because it is the absorbance of a solution of unit concentration and unit path length. The path length is always defined in centimeter and that of concentration in gram per liter. Absorptivity is the measure of ability of sample to absorb light. Molar absorptivity. It was formerly known as molar extinction coefficient or molar absorption coefficient. Molar absorptivity is the product of absorptivity and molecular weight. Mathematically, molar absorptivity is denoted by epsilon. So mathematically you can write epsilon is equal to small a, that means absorptivity, into capital M, that means molecular weight. Absorptivity क्या है? A upon BC. Therefore, instead of writing small a, you can write A upon BC into molecular weight. Now, path length. Path length, it is denoted by letter L or D. It is the internal thickness of the cell in which the test sample is taken. Internal thickness in which the test sample is taken. Now, before going again deep study, you must know the fundamental law of photometry. When light, monochromatic light or heterochromatic light is incident upon homogeneous medium, a part of the radiant power of incident radiation, see here in this figure, when we incident monochromatic or heterochromatic light upon a homogeneous medium, a part of radiant power of incident light is reflected, a part is absorbed by medium, and remaining part is transmitted. See in this figure, which is absorbed, it is denoted by PA, which is reflected, it is denoted by PR, which is incident, it is denoted by P0, and transmitted, it is denoted by P. Now we will continue the fundamental law of photometry in the next presentation. तब तक के लिए अल्लाह हाफिज़. Thank you.